Hello, my dear Byju's achievers. Welcome to yet another session on your very own channel, Byju's ninth and 10th. Yes, so as you all know, I'm not actually here. I'm recording this video for you because I'm on leave. Something urgent came up. But just because your study should not stop, and that's why I'm doing this, all right? So please cooperate. Please understand, try to understand and try to answer everything, because you know what, my content team is there in the chat window and they're answering each and every conceptual doubt. All right, so yes, this is the best I'm trying to do from our side. I mean, come on, let's cooperate and I'll see you again. Don't worry, in the next session. Fine. All right, so the session we are doing today is the NCRT exemplar sprint of light, reflection and refraction, NCRT sprint session 1, right? I mean, you have learned almost, I mean, I would say not almost, you have learned quite many of the concepts, right? It's good we practice them, right? It's good that we practice them and then move towards the next set of concepts, right? So, come on, today's session is all about practicing questions. So, I want answers from your side, I want support from your side, I want you to look for all the concepts hidden in your head and use them today, all right? Come on, this will be a great session. Let's rock. Fine. Okay. Now, there's one thing which was left unanswered in the last session. That was the explanation for the magic bulb video, right? We were able to see the bulb, but it was an image. But where's the bulb? That's something which was left unanswered, right? There was some technical glitch. So that's why. First of all, I'll show you that video. Then I'll show you who all answered the homework question, and then we'll move on to the questions. All right. Come on, let's see the magic bulb video.
Okay, so you can see a weird little setup in front of you.
Yes.
The only thing I want you to look at is this light bulb.
Okay.
Cool. Now you'll see a button in front of you. I want you to press that button and see. Bulb is glowing.
Yes. Yeah.
Fine.
Yeah.
Press it again. You will see. Yeah, cool. So now I'm gonna remove this bulb. Press it again. Nothing's there, so nothing's gonna glow.
Yeah.
Cool. Now you'll see a hole in front of you.
Alright.
Cool. Look through that hole. Okay, and press the button. What do you see?
There is a bulb, so maybe.
What's happening? What do you see? What do you see?
What? It's crazy. But how come?
What do you see? What do you see? What do you think is happening? Is it magic? What do you think?
So, like really, I don't know what is it.
It's time to explain our trick. Now, do you remember this mirror that I showed you earlier? It's actually a concave mirror. This light bulb, which when I press this button, it glows. Now, no matter where you are in the room, when I press this button, light from this glowing light bulb is going to fall on your eye and you're going to see a light bulb there. But when I remove it, there's no light coming from here. So when I press this button, you're not going to see anything there. But if you look at it from this hole over here, you are going to see a light bulb, or it's gonna seem to you like there is a light bulb there. What could be happening? Well, an image of a light bulb is forming over there thanks to this concave mirror. But what's the object? So if I rotate the setup like this, you can see that if I press this button over here, there's another light bulb down there. That is my object. Okay, so when you look at it from this view, you'll see that when I press this button, the light bulb below is going to glow. That light is going to fall on the concave mirror, it's going to reflect back, and it's going to form an image over here. Then it's going to keep going and fall on the eye of the person who's looking at it from here. Okay, so that's about it. That's the whole trick explained right there. But for those of you that have learned a little more about concave mirrors, I just want to add a couple more things. You'll notice that the image is inverted with respect to the object, and it's real, and it's the same size as the object. Now that's important because I want the person who's looking at it from here, I want him or her to think that it's the same light bulb. Okay. Now you'll also notice that both the image and the object are at the exact same point. They're at the same distance from the concave mirror, and that only happens when the object is at the center of curvature.
Well, yes, now you know, right? I often say this to my students. Things are always magic until and unless you know the science behind it, right? Now you know the science behind it. For you, it's a scientific setup, it's not a magic trick. Fine. And that's how spherical mirrors are used to pull off these tricks. Cool. Nice. Alright, there was a homework question which we asked. Tina went to purchase a makeup mirror and she saw three different mirrors which look alike, but her image is different in each of them. Can she choose mirror just by looking at her image? If so, what were her requirements? So she wanted a makeup mirror, and yes, I'm pretty glad that I would say all of you answered correctly, right? Yes, Lakshmi said yes, erect, same size, virtual also. Magnified, I would say, because makeup mirror, shaving mirror, makeup mirror, they tend to go for magnified images, right? So that's why. Fine. All right. Srishti, Nivedita, and Amrita. And yes, there were some nice comments also. I like reading those comments. Thank you. Thank you. All right. You guys are truly amazing. I like the enthusiasm. I like the way you respond. And yes, this is what makes a great session, right? I would say this is what makes a good session a great session. Not a great session, good session, right? That's why. Pradeep, Sonali, Apta, Nakul, Arush, Manoj, thank you for all your responses. Let's move on to questions now. All right, come on. Let's take it slow. We'll build up slowly, right? Let's take the first question. The laws of reflection hold good for, tell me. Laws of reflection hold good for, is it only plane mirrors? Is it only concave mirrors or only convex mirrors or all mirrors irrespective of their shape? Now, you know what? You can put up your answer in the chat. Yes. Come on. Come on. Yes, I can see. I'm imagining. I'm hoping that what is the correct answer. And anyways, content folks are there. My team is there who is just able to answer, see whatever answers you are putting on. So yes, please put your answer in the chat. Is it A, B, C, or D? Go on. I think most of you answered this one correctly, right? Nice. All right, let's just give a quick explanation for this. The laws of reflection hold good for plane mirror, concave mirror, convex mirror. See, it's the laws of reflection, right? Not the laws of reflection for plane mirrors or for convex mirror or for concave mirrors. Wherever there is reflection, these laws will hold true. And we have learned this, right? Curved mirrors is nothing like minute plane mirrors stashed together to form a curved surface, right? So that's why this is what is happening. It's reflection happening, and that's why the laws of reflection hold true. Simple. So that's why the answer would be, okay, I'll just show you first of all that what kind of reflection. You will see I equals R. Here also, you will see I equals R because this is normal. This is normal, right? The convex mirror, if you see, again, I would equal to R, right? So that's why angle of incidence equals angle of reflection. Why? Because all these are normals only. Fine. So that's why it holds true for all mirrors irrespective of their shape. Fine. All right. Let's see the next question. Which of the following ray diagrams is correct for the ray of light incident on a concave mirror as shown in the figure? So this is the question, and then 4 are the options completing this question's partial diagram, right? So what is given to you here? There is a, which mirror is this? Concave or convex? Come on, we know this, right? Curved inwards, and reflecting surface is the inwards, polished on the outward surface. It's a concave mirror, definitely fine. Now, the ray is parallel to principal axis. Now, we know this. There is a set of special rays, and this is one of those special rays, right? What happens to this ray after reflection? Come on, think. Right? Come on, think. See, we have learned this. And we have learned this quite clearly, right? So, come on. Let's see the special rays first, and then you can choose which one is this one, right? So let's see. Passing through focus. If there is a ray which passes through focus, falls on the mirror, after reflection it becomes parallel, correct? If a ray is parallel to principal axis, after reflection it is bound to pass through focus, right? Fine. A ray which is incident at pole, simple. It goes like a plane mirror kind of thing, right? I mean, it is symmetrical from the principal axis, I would say. Fine. Okay, passing through C. The good thing is, whatever rays passes through C falls on the mirror, it is actually falling perpendicular to the surface. It will go, or it will retrace its path back. That's why. This is passing through C. So, which one is this? This is option D. The ray is parallel, means after reflection, it will pass through focus. Correct? I don't think there must be any doubt till now. Nice. And I can see that most of you are answering correctly. Very good. Nice. Keep it up. Next question, guys. Come on. Rays from sun converge at a point 15 centimeter in front of a concave mirror. All right. Where should an object be placed so that size of its image is equal to the size of the object? This is, I would say, +1 difficulty, whatever we did till now, the two questions. This is slightly above. Why? I'll tell you. Understand the question first. See, rays from where? Rays from the sun. Where is sun? It's very far, right? Okay. They fall on a concave mirror and then converge at a point 15 centimeters. Can you tell me what is this 15 centimeter point? Can you give a name to this point? Come on, tell me. Special points. You know it. Don't tell me you don't know it. I know you know it. Tell me, come on. Nice. Okay. Good. See, I would have taken names, but I'm sure these are correct answers, right? Okay. So, converge at 15 centimeter in front of concave mirror. This point is, I'll tell you, don't worry. But I know you're answering right now. Where should an object be placed so that size of its image is equal to the size of the object? This is like the second part. Once you have understood what is this 15 centimeter point, then you can take the second part of the question. But if you did not get the first part itself, this question is a mammoth task for you, right? So, let's start first of all. Rays from sun fall on a concave mirror and converge at a point. Rays from sun are coming from infinity. They are coming from very, very, very far. So, rays coming from infinity, we can think as parallel rays to principal axis falling on the mirror and converging at a point. This is what? This is the focus, right? This is focal length given to you. So, this 15 centimeter point is focus of the concave mirror, correct? So, at least you got this. Parallel rays coming from infinity converge at focus of the concave mirror after getting reflected. Fine. So this 15 centimeter is focus. Understood? Clear? Alright. Fine. Next, where should the object be placed so that size of its image is equal to the size of the object? Now, this is a special case, you know what? And I have mentioned this in the previous session also. In the case of concave mirrors, please have a habit to at least look at these, practice the ray diagrams and have a look at what positions, what kind of image is formed. I'm not asking you to cram it, but you know what? The more and more you practice it, the more and more you'll see a pattern, right? You'll see a pattern repeating itself. When an object goes from infinity towards focus, the image goes from focus backwards. You will see a pattern. I'm telling you, you will see image increasing in size, right? This is something you will observe, but I want you to notice yourself. See, I can do a session afterwards, but you notice. So that's why. When is the size of object equals to the size of image? Can you think? All right. Let me give you more clear visualization. So, rays from sun fall on a concave mirror and converge at a point. This point is the focus, right? And is 15 centimeter is the focal length. All right. Now, this special point will be where the object size will be equal to the image size. It will be center of curvature, right? When the object is beyond C, image is between C and F. When the object is between C and F, image is beyond C. It is magnified also, but same size happens at C. And you know what? The magic bulb answer was what? There were two bulbs at the center of curvature, right? That's why you were able to see a real image. And that's why, one more thing, regarding the magic bulb itself, there was one more thing. We tend to think that we can only see a real image if it is on a screen. You know what? In the magic bulb, it was a real image. You were able to see it, and there was no screen. That's why it's a myth that do we always need screen to see a real image? No. It's an important point. Note it down. All right. Yes. So the object would be at center of curvature, and this is what the ray diagram would look like. Fine. All right. So formula is R is twice of focal length, right? 2f. So that's why if f is 15, R would be 30, and the answer would be option B, 30 centimeter in front of the mirror. Fine. Okay. Nice. Next question. Come on, let's see. No matter how far you stand from a mirror, your image appears erect. Okay. All right. The mirror is likely to be. It's a good question. I mean, I won't say difficult. It's a good question, and it's slightly tricky question. You just need to be careful, right? You just need to be careful. If you rush in this question, you will make a mistake. And I can see some of you are making mistakes. I think so, right? See, I'm just assuming, right? I'm just assuming, but yeah, I still think that some of you are making mistakes. Don't worry, my team will tell me afterwards who all made the mistake, and don't worry. So, no matter how far you stand from a mirror, your image appears erect. Okay, there is a mirror. You are there, and however far you stand from that mirror, your image appears erect. All right. Okay, the mirror is likely to be. So, can you tell me at least one mirror you can just rule out here? Concave mirror. Why, sir? Why concave mirror we can rule out? All right, I'll tell you. It's only plane mirror, only concave, only convex, or either plane or convex. All right, I think you got it till now. But still, image formed by a plane mirror. Image formed by a plane mirror, the properties are image is same distance from the mirror as the object. Fine. It is of same size. Object size, image size is same. It is virtual, it is erect, and it is laterally inverted. Virtual images are images formed inside the mirror, right? Erect images are if your object is upright, image is also upright. That is erect image. The way you see yourself in the plane mirror, right? So it's an erect image, right? It's a virtual image. It is inside the mirror. In the magic bulb, it was real image, right? Of the bulb, right? Okay. It is laterally inverted. Fine. Laterally inverted was you lift your left hand, your image will lift your right hand, or it is better explained in terms of characters. So don't worry, we'll do these things afterwards also. Okay, so this is plane mirror, always virtual, always erect, always same size. Fine. Next, concave mirror. Majority of the time, concave mirror forms real and inverted image, right? And the question is saying, however far you go, you will always get an erect image, right? Which means it cannot be concave, right? Concave gives you a virtual, erect, and magnified image only in one case, between pole and focus. Otherwise, it always gives you inverted image. Means concave cannot be, right? You just ruled out one option very clearly. Fine, concave cannot be there. So, concave always form real, virtual, inverted, or erect. Size varies. That's true. Next, convex mirror. The rear view mirror, the parking lot mirror, right? The junction mirror. What is so special about it? The wide angle view. That's okay. Image wise, always virtual, always erect, always diminished, right? That's why convex also qualifies always erect. So that's why image formed by convex mirror is virtual, erect, and diminished. Always. So that's why the answer would be either plane or convex, right? Wherever you go, image is erect. Means it could be plane or convex. Simple, right? Okay, clear, easy question, nice. Next question. We wish to obtain an erect image of an object using a concave mirror of focal length 15 centimeters. Okay, which mirror? First of all, it's a concave mirror. I would say whenever you read such kind of a question now, have a habit to mark the important keywords so that you might not forget it, right? It's a long statement. If you see, 1, 2, 3, 4, 5. At least here, you will see 5 lines. It feels, your mind says lot of information. So break down the information, right? Concave mirror, okay? A focal length 15 centimeters. Okay, concave mirror is there, focal length is 15, and you want an erect image in the case of concave mirror. All right, I think you got it. What should be the range of distance of the object from the mirror? What is the nature of the image? Is the image larger or smaller than the object? Draw a ray diagram to show the image formation in this case. If you cracked the code till here, focal length 15 centimeter, if the first statement you have cracked, means rest of the 4 questions are easy. If you're not able to crack the first statement, you will struggle. So what do you think? Which case is this? All right. It's okay. Before answering that, answer a small poll question. So this is a poll question. You answer it and then we'll think what to do for that question, right? This poll question is: image formed by concave mirror is observed to be virtual, erect and larger than the object. Where should be the position of the object? All right. I'll give you 30 seconds and your time starts now. Yes. Image formed by a concave mirror is observed to be virtual, erect and larger than the object. See, this poll question is meant to support you so that you get power to answer that previous question which is ongoing. All right. So that's why. Come on. Think. It's easy. Come on. All right. Virtual, erect, and larger than the object. This is possible in only one case: when the object is between pole and the principal focus, right? Remember? Otherwise, it's always real, inverted. True. Size varies is fine. It's not virtual, it's not erect. That's true. All right. So, let's see. We wish to obtain an erect image of an object. You only get an erect image in a concave mirror when it is between pole and focus, right? Then only you will get what? A virtual, erect and magnified image. Fine, your focal length is 15 centimeters. All right. So the next question is, what should be the range of distance of the object from the mirror? From pole to focus, from 0 till 15, right? So between F and C is this. At C is this, beyond C is this, and between P and F is this. So these diagrams will come really handy if you know them properly, right? Okay. So between F and P, if you want to make the diagram, you can make it like this. You have chosen 2 special rays. One is the center of curvature one and one is the pole one. You could have also taken this one, a parallel ray passing through focus. It would have met again at the same point. Not a problem, right? You need 2 rays. Any of the 2 special rays if you take, you will get the same image at the same point. Fine. Okay. So this is between pole and focus. That's why image formed will be virtual, erect and magnified. And the, oh sorry, my bad. And the answer would be, range of distance will be from 0 to. Tell me, come on. If you were to write answer for this question, you will write the range as 0. Give number to your answer. Come on, think. Your range should be more than 0 and less than 15. So why not less than equal to 15? Tell me, if you put object at focus, the image will be real, inverted, highly magnified. And where? At infinity. So that's why it should be between, right? So that's why I'm not using equal to signs here. So that's why, fine. And next is nature of image. You have learned. Larger or smaller? Larger. Ray diagram? You have just learned. Simple, easy question. Okay. Let's see the next question. A full length image of a distant tall building can definitely be seen by using. It's a slightly good question. Yes. There's a small trick in this question. Come on, think. Full length image of a distant tall building can definitely be seen by using. There are 1 or 2 words in this question statement which are giving you a hint. What are they? Go on, think. What are they? A full-length image of a distant, tall building. There is reason I'm speaking like this. I don't usually speak like this. Come on, think. A distant, tall building. Okay. Right. Then what? Okay, I'll give you a hint. Mirror should provide a larger field of view. The reason of saying a distant, tall building is mirror should be able to capture this tall structure. Means the mirror should have a wider field of view, right? It should have a wider field of view, wider than a plain mirror. I think this much is enough. Till here, if I have given you an idea, you have understood the question. Come on, tell me, which mirror is this? Convex, concave, or plane? Tell me. I'll give you three options here. Yes, it's a convex mirror. Why? Because convex mirrors are diverging. They form virtually, right? Virtually erect diminished images, but they also have a wider field of view, and that is one of the reasons they are used as parking mirrors, junction mirrors, rear view mirrors. Fine, got it. And that's why this is the answer, a convex mirror. Fine, okay, got it. All right, let's see the next question. A child is standing in front of a magic mirror. Okay, magic mirror, not the magic bulb mirror. This might be something. Let's see. Let's read the question. She finds the image of her head bigger, the middle portion of her body of the same size, and that of the legs smaller. Okay. The following is the order of combinations for the magic mirror from the top. Okay, I'll explain you the question first. Understand the question. There is a child standing in front of a mirror. Forget magic for now. Hai na? A child is standing in front of a mirror. And what she sees is her head in the mirror looks big. All right, means magnified. Okay. Her middle portion of her body, right? The middle portion, it looks of the same size. Okay. And the legs appear smaller. Smaller. All right. The following is the order of combinations for the magic mirror from the top. And if you see the options, what do you see? Plane, convex and concave, convex, concave, and plane, concave. Means this mirror is like divided into three sections. I'll visualize this to you also. See, let's say this is the child. Her head looks big, same size, and this is thin or smaller. So one thing you can be very sure of, like whatever mirror is this, she is able to see her image in the mirror, right? In the mirror. Means images are virtual. Images are erect, right? At least you can be very sure of two things. Images are virtual in all the three mirrors. Images are erect in all the three mirrors. You just have to see in which case you are getting, right? In the first case, this first case, you are getting a virtual, erect and magnified image. You are getting here a virtual, erect and same size image. And here you are getting a virtual, erect and smaller image. This much hint is enough to answer this question. Between F and P, if you put an object in front of a concave mirror, you get a magnified image, a virtual, erect and magnified image. True. Means the first mirror is concave, right? Condition is between F and P. Second one is plane mirror. Why? Because it is same size. Object and image are of same size, right? So this is a plane mirror. All right. You will always get same size image. Fine. Next, third one is a convex mirror. Why? Because convex mirror always gives you virtual, erect but diminished image. Yes, her legs look smaller, and that's why the third mirror is a convex mirror. So that's why the answer is option C: concave, plane, and convex. You got this question, huh? If you got this question, I'm telling you, you have in this one question, you have revised a lot of things about all the three mirrors, right? So that's why it's a good thing. Practice questions, practice more and more questions. Fine. All right. Let's see a quick poll question for you. Let me just check how you are doing. In torches, searchlights, and headlights of vehicles, the bulb is placed. You have four options: between the pole and focus, very near to the focus of the reflector, between focus and center of curvature, at the center of curvature. I'll give you 30 seconds. Let's see how many of you get the correct answer. Fine. Your time starts now. Yes. Torches, searchlights, and headlights. So, to answer this question, I would say think What is the use of torches, searchlights, and headlights? Why do we use them? If you know, if you understand this, the answer is pretty simple. One. All right, time up. So, what do you think? Torches, searchlights, and headlights. Why do we use them? We use them because you want this light to just go to infinity, as far as it can go, right? That's the use. Fine. That's why we use torches, searchlights, headlights, right? So, what do you think? When I say reflector, which mirror am I referring to? Come on, first of all, answer me this. When I'm saying reflect in all these four options, what is the type of mirror I'm referring to? Yes? Nice. It's a concave mirror, right? It's a concave mirror, right? Yes, you're correct over there. Reflector is concave mirror. If you put an object at the focus, what happens? Light will go to infinity, right? So that's why. Very near to the focus of the reflector, and that's why, right? Okay, got it? At the focus, if you put an object, light rays will fall on the mirror and go for infinity. Image will be formed at infinity. Fine, that's why. This is the correct answer. Name the type of mirror used in the following situations: headlights of a car, side or rear view mirror of a vehicle, and solar furnace. Support your answer with reason. The first one we just did in the poll question, right? Headlights of a car. See, requirement is that the image should be formed at infinity. The light should travel to infinity. It's okay in between if there's fog or something, that's okay. But your requirement is how far the light can go, it should go, right? So that's why you will place the bulb at the focus or very near to focus. It will fall on the mirror, concave mirror, and then go to infinity, right? So that's why. To create a parallel beam, headlights of a car. Next, side or rear view mirror of a vehicle. Side or rear view mirror. What is your demand? What do you require? You want to see a wide frame, right? You want to see the whole road. If it's let's say it's a bigger road or wider road, you want to see the whole road behind you, right? You want to see who is coming from what side and everything. So that's why rear view mirrors, you want always an erect image, you want a virtual image, you want to see the image inside the mirror, right? You want come on, you want erect image also. You don't want that car is coming from behind and you are seeing car upside down in the mirror, right? You don't want that. So that's why you want virtual, you want erect. Now the thing is, only convex mirror are possible case in this, and they always form a diminished image, right? So that's why they provide a larger field of view. They are able to cover more area. That's why you have a wider field of vision, and this enables you to be safe on the road, right? For safety purposes, rear view mirrors are used. Fine. Okay. Third one, solar furnace. Furnace. Using the energy of sun, using the sun's light rays to produce so much heat that you can use it maybe to cook food. It's not oven, but still it's the furnace. Furnace means to generate more heat. So how will you generate? If you converge the light beam. Who is a converging mirror? A concave mirror. So that's why a concave mirror is used to converge light, because light from sun is coming from infinity, very far. It will fall on the mirror and converge at a point. That point is focus. Simple, right? That's why solar furnace is concave mirror. Fine. All right. So if you have understood till now, if you were able to answer, I'm not saying all correct answers, I'm saying if you were able to try at least all the questions, it's an achievement for me. Don't worry, we'll practice more and more questions. But for today, this was the last question, and I'll give you another homework question. Yes, and I want to see the answers in the chat. Don't worry. When I come back, I'll take the names of people who answered well, right? Don't worry. Take a spoon in one hand and a pen in the other. Try to move the pen closer to outer surface of the spoon. Observe the image of the pen formed by the spoon. Repeat the same activity with inner surface of the spoon. Which surface of the spoon acts like a convex mirror? It's an observation based question. And I want to see, what do you observe when you go close or move back, right? I would say take a screenshot. I'm just bending down. Take a screenshot and observe this thing. Explore the world with the eyes of a physicist. Fine. Explore it. Tell me what you see, and we'll discuss in the next session. All right. So, guys, that's why I tell you, and you know what? Not just me. We all say this to you. This is Byju's, and we have got you covered. We are trying to get you covered. Fine. There is a trial class description in the link, so you can try it. It's free, right? Go ahead, enjoy the class, and don't forget to like, share, and subscribe. Right? Spread the word to all your friends, all your classmates. Right? In school, you might meet new people. Tell them that we are doing this thing. It's good if you think it's good, right? And we'll have a group study session. Come on, spread the word, and I'll see you again in the next session. Definitely. All right. Till then, take care. Bye bye.